Welcome back, ladies and gentlemen. We are going to take a look at our second learning target for this lesson on trigonometric ratios. Okay, so to start off, we have some key vocab for you. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. Okay, now we say ratio, we're talking about a fraction. We're going to be making some fractions here. Okay, numerator, denominator, so on and so forth. The three basic trigonometric ratios are sine, cosine, and tangent. However, like we always talk about, we like to keep things short and simple. We like to abbreviate them. So for sine, S-I-N-E, we like to write the word S-I-N. Now, please make sure you don't pronounce that sin. Still call it sine. Okay. For cosine, we write down the word cos, which cosine. And for tangent, we write down the word tan. So you've seen these before. They've been staring you at the face in your calculators for years. You never knew what they were. We're going to find out what they are today. Right? Our trigonometric ratios. So over here we've got a triangle. Let this be triangle ABC be a right triangle. The sine, cosine, and tangent of acute angle A are defined as follows. This is important. We have to have an angle to go off of. This is piggybacking on our lesson from our previous lesson for our learning target number 1. So we're talking about angle A. You first label your hypotenuse, your opposite, and adjacent, just like we've been doing. The sine is always opposite over hypotenuse. So whatever number this is, that is on your numerator. Your hypotenuse, whatever number that is, that's your denominator. It's that simple. You are just creating a ratio, okay? Sine is O over H. Cosine is adjacent over hypotenuse. So, okay, your adjacent side, B, over your hypotenuse side, C, B over C, A over H. And then finally, your tangent is opposite over adjacent. Okay, opposite over adjacent, boom. Now, this is tremendously important. I can't stress that enough to you. You're going to be seeing this years down the line, like you really will be. Okay, so it's kind of hard to look at this and go, hey, how do I keep this in the back of my head? So here's one of the most applicable acronyms you're ever going to see in math. Okay, SOHCAHTOA. So sine of an angle, S, is equal to O over H, opposite over hypotenuse, O over H. So, cosine, the C stands for cosine, A over H, adjacent over hypotenuse. And finally, TOA, tangent of an angle, is opposite over adjacent. Okay, so, TOA. You will see this for years to come, like you really will. Okay, we're going to have this all over everything to help you guys out. So our first thing we're going to do here is, okay, we're going to take a look at two examples. Find the sine, cosine, and tangent of angle P. Now they're telling me the angle P. The directions are important here. Circle my angle P, just like we did in our previous lesson. We're going to label our three sides, okay? First, here's my right angle. Across from it, there's my hypotenuse. There's your HYP. Across from your angle P, opposite of it would be your opposite, OPP. And then lastly, the side adjacent or next to your angle, but not the hypotenuse, is your adjacent. Okay, cool. So sine of P, we write this out as sine P equals, you'll notice it's written up here as over H, opposite over hypotenuse. You do not have to write that every time, but it's a good guide. All I do is I look over here, my opposite, what number represents opposite? Well, we labeled it 15. Your hypotenuse over here, the number that labeled for hypotenuse is 17. Done. That's it. Sine of P is 15 over 17. Cool. Move on to cosine P. Notice our ratio changes. Adjacent over hypotenuse. ADJ over HYP. Okay. Over here, look at what you labeled, because we have to label them first. Adjacent is 8. My hypotenuse over here, again, is 17. You're going to see a lot of repeats. Cool. 8 over 17. Done. That's it. Okay. Finally, tangent of P. We're looking up here, opposite over adjacent. We look at what we labeled. Opposite is 15. Adjacent is 8. Done. Great job. That's all there is to it. Okay. So I'm going to show you guys one more example, which adds one little extra thing to it. Nothing too big. Angle is X. Circle it. Okay. Every time for this, when we're talking about trig, you label opposite, adjacent, hypotenuse. Okay. Here's my right angle. Notice it's changed. Go across from it. There's my hypotenuse. Find your angle. Go across. Okay. Going across. There's my opposite, which leaves my last remaining side as my adjacent. Okay. Sine of X. Now, sine, again, opposite of hypotenuse. All right, so opposite is 16, okay? And hypotenuse is 20. Great. So here's the thing. We always reduce, all right? You got to get this in your head. We're going to always reduce in math. So 16 over 20. What number can go evenly into 16 as well as 20? 4 would be your highest one. So 16 divided by 4, okay, gives me 4. Just dividing by 4 here. All right, and then 20 divided by 4 is 5. Boom, got it. All right, we always want to reduce. Sine's done. Cosine. Again, use this as reference. Adjacent, adjacent over hypotenuse. All right, so over here, my adjacent is 12. My hypotenuse is 20. 12 over 20. Let's reduce. What number can go into 12 as well as 20? Think about it for a minute. 4. 12 divided by 4 is 3. 20 divided by 4 is 5. Life is good. Okay. One last one. Tangent of X, okay, is opposite over adjacent. So my opposite is 16. My adjacent is 12. Looks great. Let's just reduce it down. Kind of noticing a common trend here. It won't always be the same number, but this one it is. 4 can go in on both of them. 16 divided by 4 is 4. 12 divided by 4 is 3. You guys rock. Okay. So, yeah, it's as simple as that. SOHCAHTOA is where you're looking for. Okay. So great job, guys. Keep up the good work. And as always, good luck. We're all counting on you.